So yeah, please join me in welcoming Patrick Chazon from Microsoft. He is a principal cloud advocate. They're working on making Azure the cloud provider that we all love. And fun fact, before that, he was actually working at Docker, and I was on the stage, and he was right here introducing me. So look how tables turn today, right? Payback time. So yeah, let's give him a round of applause, and then he's ready to go.
Thanks. It's really good to be on that side too. So thanks. So hi everybody. So today I'm going to tell you a little bit about how to develop apps with containers, but also functions and cloud services. A little bit about myself. I'm French. I'm from Paris originally. One note, the Docker team was gentle enough to give us presenters some really nice slide designs. And in there are some really cool assets, such as the Gordon little turtle there. So I've hidden lots of Gordons all over that presentation. The one who gives me the number of Gordons hidden in that presentation will win a t-shirt. Okay, so I'm from Paris. I've lived in San Francisco for the past and I've been doing technology, both as building platforms and then evangelizing them at lots of different companies. Past 4 years at Docker, so I'm really thrilled to be back to give this talk today. One of the things that really interests me in software is developer productivity. This is, I think, the most important thing as an industry that we need to fix. Docker was had a real big impact on developer productivity, to improve productivity. And at Microsoft, our mission is to empower every person and every organization on the planet to achieve more. And that started with developer tools. Microsoft started with BASIC initially. And so there's still a lot of that DNA at Microsoft trying to improve the dev experience and productivity. So the premise of this talk is that in the past 4 years, while we all started as an industry to build what is kind of known today as cloud-native applications, there are a few abstractions that emerged as the base abstractions that everybody's using to build their applications. And there you have containers, what people call serverless, which is functions triggered by events, and then managed cloud services, where you don't manage the service itself, you let your cloud provider manage it. Building applications with one of these components is very easy, usually very well documented. You just go through the documentation of your tool and it explains to you how to build with containers or how to build with functions. But then when you try to mix the three of them, it becomes more complicated and you have to assemble lots of different tools. The goal of this talk is to give you an overview of lots of different tools that have appeared in the landscape to try to help you merge all that stuff and have one workflow. There are many different styles of workflows, and I guess it will depend on what your requirements are or your preferences or the technology that you're using. I'm going to try to give you a good overview of all the different tools so that when you come out of this, you can determine the ones you want to try for yourself. And I'll have a bunch of demos there. So first, talking about containers, you saw the keynote this morning. Docker really built this stack that's based on containers that goes from the developer laptop with Docker Desktop to the enterprise edition that's running on servers. In there, Docker, the product itself, is something that's built out of different components that are part of the Moby projects. So you have components like Containerd, which graduated recently in CNCF, or BuildKit that helps you do the build. And these components themselves, they're based on specs that as an industry we all gather together to create under the umbrella of the OCI, the Open Container Initiative. So Kubernetes emerged as the standard for orchestration of containers over the past few years. And whatever kind of container platform, or for most of the container or people running containers, they will end up running them on Kubernetes, except some people who are running them on Mesos with Containerd. Docker Desktop ships Kubernetes on your laptop. So when you're on your laptop with Docker Desktop, the latest version, you can go in Preferences and activate Containerd. And then in Azure, if you're using Azure as your cloud provider, all the cloud providers have some kind of managed Kubernetes offering. At Microsoft, we have a very broad view of our containers, so there are lots of options. From app services to service fabric. The one that's the main one, I would say, is AKS, Managed Kubernetes offering by Microsoft, where we manage the control plane and you can manage the nodes. And then Docker Enterprise Edition, which runs really well on Azure. There's an interesting project or an interesting option for running containers in Azure that's called ACI. An ACI, Azure Container Instances, allows you to take all of Azure as your capacity for running containers. You just specify an image and the isolation characteristics that you want, and it's going to create VMs based on that, on these VMs. And together, it goes with an open source project that's called the Virtual Kubelet. That's part of CNCF. And the Virtual Kubelet acts as a virtual node in your Kubernetes cluster. So when you're scheduling a container talking to Kubernetes, you're talking to the Kubernetes API server. You tell it, hey, I want to schedule this kind of container. This API server is picking one node typically and talks to the kubelet on that node, and the kubelet is going to use a container runtime like Containerd to schedule a container there. With the virtual kubelet, instead of that, your API server is going to talk to that virtual node that then will use the API of ACI to create as many containers as you want with having all of Azure as your capacity. So that's a different option. Functions, so serverless is a term that I don't like very much, but it really took off in the industry. The interesting part of it is that it means that as a developer, when I'm using a platform like that, I don't need to care about the servers. Typically, I have event-driven scalability, so the platform takes care of the scalability of my functions for me. And one of the very important aspects that's important is pay per use. So you pay only for what you use. Function as a service is at the center of serverless, and in Azure we have Azure Functions. That's our fast offering. Azure Functions has a bunch of functionality. The one that's really interesting is this notion of binding to isolate your function code from the inputs and the outputs, so you can declaratively explain what the inputs and the outputs are going to be, and then you can plug that to some other things later on. And there are a number of ways to deploy them on Azure. But the important bit here for developers is that the Azure Function runtime is open source, which means that you can run it on your own infrastructure or on your laptop in a Docker container. That's what I'll show you in a bit. When you're structuring an app that's based on functions, you have these two models here. On the left, you have a dev that goes to a single-page web app that then talks to HTTP functions. Or you have devices that send events to an event queue, and then that triggers some functions. So now Azure Functions is the offering on Azure, on Microsoft platform, but there are lots of different serverless frameworks that are portable and that run on any Kubernetes cluster. So the drawing that you see there that are kind of the architecture of how a fast offering works are coming from the CNCF Serverless Working Group report on serverless. If you're interested in that topic, I highly advise you to read that doc. It's really interesting. There are many of these frameworks. I'll just talk about like 5 of them that came to DockerCon in the past few years. So FN is a project by the Oracle team. It's open source. What is most interesting in FN is a sub-project called FN Flow, which allows you to compose functions together. And in order to specify that composition, they implemented in Java the Futures API, which means that you can express the composition of your function in native Java. And then the Flow engine is going to distribute that on your Kubernetes cluster and manage that for you. Nucleo is really interesting for its performance characteristics. It's coming from the team at Iguazio, and it's really designed for high performance computing. OpenFast is the easiest to start with. It's a very good developer experience, and there's a big community around it. I gave a talk in India about all this last week, and there was, at the meetup in Bangalore, there was an OpenFast contributor. And I think many of the meetups where you go, you'll find some OpenFast contributor. Alex Ellis, who built OpenFast, really succeeded into building a community around it. Galactic Fog, very enterprise-oriented. It has lots of role-based access control characteristics. And then OpenWhisk is, I'd say it's the oldest of these function-as-a-service projects. And it's being rebased right now on a new project called Knative. So I'm going to talk briefly about that. Knative is a project by Google. And the Google stack nowadays in open source is Kubernetes plus Knative plus Istio. And Knative is kind of the function as a service plus events management platform that's portable, and that's a middleware that you can build experiences on top. And so there are two experiences that have been built on top of Knative. One is the OpenWhisk project, which is rebasing on top of Knative. And the other one is Riff from the Pivotal team that's also rebased very early on top of Knative. And then managed cloud services, typically for your database and other data services, more and more people are not managing them themselves. They rely on their cloud providers' managed services for that. And there's an interesting project to take a look at for these, which is called the Open Service Broker. So Open Service Broker was a component of Cloud Foundry. So Cloud Foundry lets you provision managed services and then bind them to your application that we're running on Cloud Foundry. The Cloud Foundry team extracted that component and gave it to CNCF in the open source broker project, which is an open source project. And then you can have some implementations of that open source project for different cloud providers. So there's one called Open Service Broker for Azure. And if you install it on your Kubernetes cluster, you'll be able to manage managed services in Azure from kubectl directly. So then that's one thing to take a look at if you want to normalize the way you're talking to these managed services instead of using the AZ CLI. Then there's a bunch of open source tooling. At Microsoft, we're involved in many of them. Helm is a package manager for Kubernetes apps. Visual Studio Code is used by lots of developers, and there are lots of extensions that have to do with containers and with functions. So I talked about Helm. Draft. Draft is one that's used for automating the developer workflows. And now let's talk about so I talked about kind of all the projects. Now let's talk about the different workflows that you can have with these three abstractions. So in order to categorize that a little bit, I made that table where you have these three components: containers, functions, and services, and then there's your code. And then these workflows differentiate by what you have local and what you have in the cloud. So I'm going to look at each of them in turn. The first one is based on Docker Desktop. So you've seen some demos of Docker Desktop this morning. Docker Desktop, basically, you're using Docker Compose for local development. And then the Docker team has open sourced the Docker Compose Kubernetes extension as an API aggregation that you can deploy on your own Kubernetes cluster that lets you use Docker to deploy Compose files onto Kubernetes. And so on that developer workflow, you have typically your code, which is mounted in a volume in a container. Docker Desktop implements a deep tie between the Linux file system inside of the VM where the containers are running and your Mac. So that means that when you're modifying a file on your Mac, iNotify works on the Linux side and can restart your server automatically, if it's a Node.js application, for example. Your containers are running on the local Kubernetes cluster. And then one other thing that's interesting if you're using something like Azure Function or one of these serverless portable frameworks is you can develop your Azure Functions code locally and just mount it into the Azure Function container runtime. And then for services, typically you're going to have either MySQL or MongoDB or whatever service you're using has probably a Docker image running or on Docker Hub that you can run there locally. And then when you're going to deploy, you could deploy that to a cloud service. So let me show you a demo of that. Yeah, and then there's Docker Enterprise and app templates that Docker introduced recently. So here I have a very simple Spring Boot application that's called Spring Doge that my friend Josh Long created. And so it's a Java Spring Boot application with so it has one web service, and then it's using MongoDB as a backend, and it has an Angular JS frontend. And what the application is doing is it lets me drag and drop an image. It's going to modify the image and then store it in MongoDB and serve it to me. So that's a classic Spring application. In order to Dockerize it, I have a very simple multi-stage build Docker file. So here I'm using a Maven image to compile it. I do a Maven package in there, and then I have a second image from OpenJDK where I'm going to copy from the builder image the jar that has been created and copy that inside of the container and just do a java -jar. But then here I have my Java classic application that I haven't worked in for a year or something, and I want to start modernizing by using Azure Function. If I want to do that, I just create an Azure Function here. So here I created a very simple one called patfunc. So you can see here I have some binding, which means here it's a simple function that takes a request and returns a response. So I specify the name of the parameters, the methods that are accepted, the authentication. So here I'm going to keep it anonymous. And then it's a simple hello world application, so I can do a get on that. And when I want to work with all these things together, I can use a compose file where I have my Spring Doge image here that I have built with a MongoDB URI going to Mongo, and I have the Mongo service using a Mongo image. And then I have my patfunc, which is using the image for the Azure Function Runtime version 2 for Node.js. I'm going to expose port 8090, and I'm going to mount the function code in a volume there. And so when I do a Docker compose up for this, compose up, it's going to start MongoDB, it's going to start my Spring Boot application, and then I should be able to go to localhost on port 8080 to see my application, and there I can take a picture, and let's go to, I don't have anything in desktop. Maybe in downloads I have a few pictures. No, I have the code for the Virtual Kubelet that won't do as a nice picture. So let's take that PNG, and I drop it there, and it's going to add a bunch of gobbledygook on that. So that's what this application is doing. But what I wanted to show you there is that at the same time, on the port 8090, I can have my function that's running there, and if I go curling it if I do a curl on localhost 8090 and I give some parameters, it's selling hello Pat. And when I'm in development, I can go to index.js, and instead of saying hello, I can say bonjour, and I change it, and right away it's going to take effect. So that's my development workflow with Azure Functions and a Java application in containers. So that's the Docker workflow. It's pretty simple, it's well known, but it works really well. Now, another experience I wanted to show you is called Azure Dev Spaces. So Azure Dev Spaces is actually a service that's running in AKS, so Azure Kubernetes service that's running inside of Azure in conjunction with a local command line tool called AZDS that's triggered by Visual Studio Code extension. And so that whole thing gives you a workflow where I can take an app that has like no containerization in it, like a basic Java app or Node.js application. I use the Visual Studio Code extension to just initialize it. So I'm just going to show you that. To initialize it, and it's going to create a Docker file, a Helm chart for me. And then I can say, I can press F5 to start debugging, and what it's going to do is that it's going to deploy it to Azure, to AKS. The extension, the local client-side tooling is going to talk to a controller in Kubernetes in my AKS cluster to send it all the code that I have changed and then set up the networking and do a network between my or proxy between my local host and the port in AKS so that I can test locally and debug locally. So it's doing all that behind the scenes. Azure Dev Spaces have a bunch of other features that allow several developers to collaborate using the same cloud services and then changing just some of the services that are part of an application. And then when you're changing things, it can continue syncing your changes back to the cloud. And it's completely transparent to the user. So let me show you what that experience looks like. So I'm just going to kill that one, and I'm going to launch, I'm going to go to this guy. So here I have a web front-end application. I'm going to just go code there. So it's a very simple Node.js application that has not much in it. And what I can do there is that I can go to View Command Palette. And there I have Azure Dev Space prepare configuration files for Azure Dev Spaces. Do you want a publicly accessible endpoint? Yes, I do. And so what it's going to do is that it's creating a Docker ignore, a Docker file, an azds.yaml. So my Docker file, it detected it's a Node.js application, so it does the right thing, and I can change it. AZDS is a configuration for AZDS, and then it creates a Helm chart in there. But the beauty of it is that it also creates a debug configuration that says launch server, and when I do that, it's doing AZDS up, and it's going to just push all my code to AKS. And actually, let me show you what it looks like. Here I'm in Docker desktop. My Kubernetes is set to path AKS cluster, so that's the AKS cluster. If I do a kubectl there, get namespaces. Actually, let me make that bigger. You can see that on my kube cluster I have a namespace called AZDS. And if I do a kubectl get all, -n AZDS. I'm going to see all the, so here you can see the webhook service. There's one service that does image prepull for me, and there's Tiller that's used by Helm. So in that namespace, there's a bunch of controller stuff that is running, and that the AZDS extension on one side talks to in order to make that magic work. And so once that works here, I'm actually debugging my server.js code, and here I can put for example, I can put a breakpoint there. And what you can see in the terminal is that the port in Kubernetes that has been open and exposed to the public is actually port forward on my machine on 64220, and if I go there, I end up in the debugger. And when I go in the debug view, I can see that I can see my request and response, and I'm really debugging the application. If I continue, I can see that here I'm really in the debugger. I'm debugging that application from my machine to a Kubernetes cluster with port forwarding without like doing anything special. So I found that a pretty nice experience when I saw that for the first time. But then I saw something even better, which is so I'm mentoring a student. So AZDS, the code is synced to the cloud, and then the code is started in AKS. The containers are running in AKS. If you're adding Azure Functions and Azure Cloud Services, you can all have that in Azure. So I'm mentoring a student called Luca, and he's in 11th grade. And while I was preparing this talk, I was mentoring him into how to create a Rails application. And I got very frustrated. We were on video conference, and I told him, hey, you should do a RakeDB create, or I really wanted to go through the looking glass and start touching his code and his terminal. And actually, there's something in VS Code that exists that allows you to do that. It's called VS Code Lifeshare. So you just need to have VS Code. And then if you're sharing it with someone else who has VS Code, they get all your code, access to all the code is streaming from one machine to the other. You can co-edit the code together, and they don't need to have any of your tools installed. You can share a terminal and share some hosts. And what I wondered when working with Luca is, could that work in conjunction with AZDS, with Azure Dev Spaces? So then Luca could debug my application in my Kubernetes cluster without even knowing what Kubernetes is or having kubectl installed. So that's what we're going to show you now. So I'm just going to call Luca. I tried that before I join here. So let's see. Hey, Luca, can you hear us?
Yeah, I can hear you.
Okay. So there's a bunch of people in the conference who are going to look at your desktop. So can you say who you are?
I'm Lucas Nui. I'm an 11th grader at Pepperdine School. I live in the East Bay, and Patrick has been mentoring me for the past month. I've been working with Patrick on Ruby on Rails, and I've been using Lifeshare to communicate with them and fix all my errors. And we've been using Lifeshare for that, so demo and more different.
Okay, so let's see it in action. So I'm just going to go back to Visual Studio Code. And there, I still have my project with my server.js. Oh, actually, I can see you already. So I haven't shown you that, but we created a session already. But in order to share to share a session, you just click on Lifeshare there. You need to log in with an Azure account or a GitHub account, and it gives you a URL that you can paste to and give it to anybody. So I gave it to Luca. When he clicked on it, let's see what happens on your machine. So here, Luca is sharing his screen. So when he clicked on it, all the code ended up on his machine. So all the code ended up on his machine, and when he edits the code, I can see him editing the code there. So we can collaboratively create syntax errors. It's really a wonderful new system that before you had to do it, each of us had to do it on our side and use Git to collaborate on our syntax errors. Now we can do it live, the two of us. But the beauty of it is that now I can launch the debugger, and here again, it's going to take all my code, push it to Azure. It's going to build the Docker file there, deploy the Helm chart, and set up the debugger for me. So I'm just going to leave it do that. And while it's doing that, what you can see on the other side is that on the Luca side, he should see my terminal, and he can see my terminal in read-only mode. But I could give him access, like write access to a terminal where he could start typing commands on my machine. So he can see the build happening. And Luca, what do you know about Kubernetes?
Not much at all.
Yeah, and it's good because you're a developer. You shouldn't know anything about Kubernetes. That's just a place where your code is running. You should spend your time in an editor. And then another thing I wanted to show you is when my code is deployed, it's port forwarded to my local host on port 6507. So I could try it out, but I want Luca to try it out. So I'm going to go to the Lifeshare extension here. And there I can see that I have a session with Luca. I could start an audio call with him. I can assign him some terminal, but I can also assign him some terminals. So I'm going to share 6507. Oh, I have shared it, 65077. So that means now that port 65077 on my machine is going to be port forwarded to his machine. So on his machine, he's going to go to localhost on that URL, on that port, and it's going to go to my machine and then to the kube cluster. So can you show us what it looks like, Luca, on your side?
So I've already done it essentially. I clicked on the HTTP localhost. It's run the server, and I have access to the debugger right here. And if I want, you can just, the Docker component set. I can click enter, sounds good. I click step over, and I click continue. Then, if I go back to and it should change to hello from Docker component set.
All right, excellent. Thanks, Luca. That was a really good demo.
Yeah, thank you so much. It was awesome.
Okay. Thanks. See you on Sunday for our next session.
Sounds good. Bye.
All right. So that was Luca and the Lifeshare extension. So I found that pretty interesting because you don't need to have anything on the other machine, just Visual Studio Code. So that can be pretty good to onboard new people in the team. The other one tool that I wanted to tell you about, and I'll tell you about it only briefly, it's called Gloo by Edith Levin from solo.io. And Gloo is a service mesh. So it's a service mesh, which means it's a control plane for Envoy that has a bunch of features, an API gateway, and also a debugger. That's why I'm telling you about that. One of the components of Gloo is called Squash. Squash has a Visual Studio Code extension, and what the extension, and it has also an Eclipse plugin. What the extension lets you do is go at your kube cluster, list all the pods, list all the containers, and say, I want to debug this container. And then it's doing its magic to connect your debugger to the process running in that container to debug it. The reason I don't go in the details about Gloo is that Edith is actually giving a talk just after this one on Squash, and she'll have lots of demo. So I highly advise you to go to her talk. It's really, Gloo is really a super interesting product. So the Gloo workflow there, it's your code is local and your debugger is attaching to your container running in the cloud. And then you can have all the other services running in your kube cluster. Another interesting approach is Telepresence. So Telepresence is a project that's part of CNCF. I think it's in incubation in CNCF. It's pretty invasive where I installed it on my machine and it installs Fuse and it needs admin access for Fuse and then it needs to manipulate your networking layer. But the result is pretty astounding where what Telepresence is doing is that it lets you select a pod running in your Kubernetes cluster and replace what's in the pod by a process running on your machine. So you run a process on your machine and then you tell Telepresence, please replace what's running in that pod by the code running on my machine. I'm just going to show you how it works. And when it's doing that, that means that the code on my machine can call to any services that's accessible in that kube cluster. And then any service in that kube cluster or in the cloud that has access to that pod can call to my laptop. So please don't hack me during the demo, because I'm kind of opening up to everything there. So the developer workflow there is that your code is local. There's no container, there's a local process that's proxied inside of a container that's running on the other side. So let me show you what it looks like. I think I have my demo of Telepresence there. Yeah, that's it. So here, I deployed a service called Hello World on my AKS cluster, and I exposed it to the world. So it's exposed through a service that's exposed through a load balancer with an external IP of this, and I have put that into an environment variable that's called $Hello World. So if today I do a curl of Hello World, file.txt, it tells me there's nothing in there. And if I do a curl of Hello World, it's going to tell me Hello World, because it's a pod that's running a Hello World image that just serves Hello World, and that's it. Now, what I'm going to do is that I'm going to use Telepresence to swap the deployment that's called Hello World in my AKS cluster and change that by run Python 3 with an HTTP server on port 8000 in the current directory on my machine here. So I'm just doing that. It asks for my password. I hope I remember it. So it's doing a whole bunch of gobbledygook, and at the end of it, it should just create. So if I do a curl of Hello World, oh, let me show you here. I have just one file called file.txt that's served by that Python process. And now if I do a curl Hello World file.txt, so here I'm doing a curl to AKS. It's going from the load balancer to that pod, to the Telepresence proxy, back to my laptop, and says hello from my laptop. I'm just going to change it to prove you that it's really running from there. So here you go. So that's really that file that's served from Python on my laptop. And then when I'm done with this, I can stop that web server, and then it's swapping the original deployment to the original pod. And so when I'm doing a curl of file.txt, there's nothing there anymore. It's the hello world application again. So that's Telepresence. It's a really good option for people who are not developing with containers today, but who still want to develop with functions and containers who would be in the cloud already. Oh, and I'm running out of time? Yeah, I'm running out of time. So I'll just go real quickly. Ksync is another option that's doing synchronization between local files and the cloud. Tilt, super interesting option. Read the blog post. It's doing all sorts of optimization between your local code and building it in the cloud and deploying it in the container very quickly. CNAB, it's a spec that Docker and Microsoft have created that allows you to package functions and containers and other stuff into a single bundle that then you can deploy anywhere, and you just need a container runtime. And the reference implementation for it is called Duffel. And Porter is a friendlier tool that Microsoft has built to do that, and it's open source. But Docker application that you saw this morning is an implementation of CNAB. So there are several implementations of that spec out there. And Docker app you can try today in the beta CLI. There'll be a bunch of things about CNAB at DockerCon. There's a panel in a few days. You can rate and share this session. I guess I won't be rated good for brevity. And a bunch of resources in there. And thank you very much. Thanks, have fun with all these tools.